Hey guys, welcome back to TSS Garage. My name is Zach Christman. Today we're going to take a look at the John Bean 9800L heavy duty wheel balancer. First thing we're going to showcase today is how to properly mount up a light truck wheel assembly to this heavy duty machine, as well as get it into the proper modes so you can balance that. For this wheel assembly, first thing we're going to want to grab is a truck spacer. This is going to allow the distance to push out on an extreme positive offset wheel, like a dually wheel, something like that, and give us enough room to operate here. We're going to add the appropriate spacing to the shaft, and we're going to use the appropriate cone or collet. Always a collet, if you have, to match the hub bore is going to be more ideal. In this particular steel application, we're going to use a universal platform, so we'll use the cone. The wheel lift is an integrated standard for this machine. Definitely helps load the heavier assemblies so we can center things up properly. We're also going to incorporate the use of a pin plate, a heavy duty pin plate with the correct lug spacing already measured out and loaded in here. Once your tooling's clamped down properly, we're going to take a look at putting this thing into the proper mode so you can get the correct round off for the assembly you're balancing. To do that, we have a function that we'll have to hit to make sure that we're in the appropriate unit of measurement, whether we want to be in ounces or grams or inches versus millimeter. So to do that, we're going to hit function and the appropriate. This will put us in millimeters. If I want to toggle back, I'm just going to select that again. Selecting the normal mode, which is going to default into a 22.5 by 10 for heavy duty application. You're gonna have the highest round off weight assembly there. The next mode is gonna toggle down to is gonna give you a 17.5, or I would consider that to be a medium duty range. And then the last mode, which is passenger car or light truck, is going to give us the lowest weight round off. And that's where we're gonna do this 1-ton dually wheel assembly at. Once we're there, we're gonna take our SAPE arm and we're simply going to place it on the outer lip of the wheel. That's going to index our spacing as well as give us our diameter. The only other piece of information the machine needs after that is going to be the width of the assembly. In this case, we're just going to touch that width number and then go plus or minus until the width of the assembly. This one's 7.5 inches is in, and then you would touch it again to enter that data, and she's ready to go. Simply close the hood and do a check spin. Once your weights are pulled up, we'll rotate the wheel. The brake does not engage in light truck mode or passenger car mode. Highlight your plane, apply your weight at 12 o'clock using your hammer, perform your check spin, balance as normal. I'd like to show you now how to properly set up a 22.5 in this example using this dual-sided cone. This is a stepped collet on the outside, which matches our 22.5 alloy that we're going to use here today. Start by assembling my collet face with the appropriate side facing out, and we'll load our wheel up. Once your wheel's in place, you want to grab the pin plate. These pin plates are going to be for a 10 lug pattern. You're going to have a 5 on 225, 5 on 285, and 5 on 335 pattern for those over the road configurations. There's also a 4 by plate that comes for 8 lug wheels. This is going to service 225 and 275 millimeter applications. Now that we've got our wheel loaded up, let's talk about getting it into the proper modes and dimensioning what you're balancing. We're simply going to touch the passenger car, truck, medium truck button here until the appropriate lights are lit up. It's by default going to be in heavy duty mode, which is going to be, your 22.5s, 24.5, super singles, things like that. If I touch it again, it's going to go to medium duty. You'll know that by it displaying 17.5 up there. And then one more will get me into passenger car light truck mode. Again, this application, we're going to go heavy duty, so no lights will be on and 22.5 will be displayed, which is an indicator to us of which mode we're in. At that point, we're gonna dimension our wheel using the SAPE arm. The SAPE arm is a two-dimensional measuring tool, so it's going to measure the distance at which our plane starts, as well as the diameter of where our counterweight placement is desired. It doesn't necessarily mean that that's the dimension of the wheel itself, it's the dimension that the plane exists of me applying the counterweight. So in the case of me wanting to do a traditional nail on weight on both flanges, I'll just simply touch that outer flange where I want to apply that nail on weight. By default, you're gonna see 10-inch wide up here. We're simply going to touch the middle width button, and then by using plus or minus, we can change the width in 1/4-inch increments, okay? If we're at 10 inches and this is a 10-inch wheel, we're gonna leave it there. We're just simply going to close the hood for it to start its check spin process. Normal will be displayed on the screen during this cycle. You should see outer weight flange lights on, indicating we're in nail on weight mode. And there's your weight configuration: 6 ounces on the inside plane, 2 ounces on the outside plane. You'll notice that this automatically applies the brake, which keeps the wheel from wanting to rotate on you during weight application. You can still power through it, but it's quite stiff. So if you hit the stop key, you're going to release the brake coupling and allow the wheel to rotate. Simply pushing it again is going to engage that brake. So what I would recommend doing is rotating your inside or outside plane to that highlighted field, hit the stop button. We know that our wheel's not going to over rotate on us. Grab our appropriate counterweight, apply the application. Once you apply the application, you can perform a check spin, and you can do that on both sides. You don't have to check spin in between each inside and outside plane. So for applying tape weight, we're still going to use the SAPE arm, but you're gonna wanna change your mode. So you're simply going to touch the ALU button here, which also has a secondary function of changing our mode to a hidden weight or a behind the spoke mode. Just gonna press that until the light sequence is where I wanna place the weight. And in this case, I'm looking for the 2 inside planes, or ALU 2P, will be displayed. When you grab your SAPE arm, you're gonna touch where you want that weight to go. So in this case, I'm gonna touch my first inside plane, and then I'm gonna continue on and touch my second outside plane. Once you dock the SAPE arm, you're ready to do a check spin. Once your check spin's complete, you'll simply rotate your wheel to the existing, whichever plane you want to apply weight at first. Highlight your plane, hit your stop key to apply the brake. And this is where this is different. Most persons using a wheel balancer with this application are going to simply apply that weight at 6 or 12 o'clock because they assume. But using the SAPE arm, we've told the machine dimensionally exactly where we want to place our counterweight. So what we're going to do is we're going to get our appropriate tape weight. We're going to spread open the spring-loaded coupler inside of the SAPE arm, pinch the weight, remove our adhesive, make sure she's clean, and you're going to move this arm out until the counter on the display zeroes out. That is the dimension and the line at which I told the machine I was applying a counterweight, and I'm duplicating that, so we're a lot closer in our accuracy. This is different from a normal hammer-on weight, which we always do at 12 o'clock. Next, we want to take a look at loading a medium-duty truck wheel. It's another benefit to the 9800 is a very precise weight placement on 19.5s, 22.5s, wheels like that. So if we're doing fleet stuff, you got these heavy 19.5 wheel assemblies. One of the better ways to tool these up is going to be to use a centering disc. This is available as an optional buy piece. It's not going to come with the balancer as a standard accessory. However, they do make these in many different OE sizes. So this one in particular is going to be a 170 millimeter Ford 19.5 pattern. And this is going to serve us as the hub bore and the backing plate. So it's kind of a 2-for-1. Simply going to slide this on, load our wheel. Next, we can grab our heavy-duty pin plate, which we're going to want to identify what our bolt pattern is. This one here is going to be a 5 on 875. Once your wheel's loaded, you're going to want to make sure you select the right mode. We are going to use medium truck for this, so that by default is going to go to a 6.5-inch wide by 17.5 assembly. We're going to change that. Since this is a steel configuration, we will default over to the nail-on weight planes. If you would like to do a nail-on sticky or a sticky, you can simply touch the ALU button until the appropriate configuration on the LEDs is lit up. Remember, again, if you're using ALU 2-plane mode, you're gonna touch both planes that you want to apply the sticky weight to, both inside and outside planes, and then simply close the hood. In this configuration, however, since we are doing nail-on, I'm going to touch the outside flange only, and then I'm going to tell it what the width of this assembly is, which is a 750. At this point, close the hood, perform our check spin. Once your check spin's been completed, index your wheel until your LEDs on the plane that you're trying to apply weight to are all highlighted. Apply your weight at 12 o'clock. Do the outside plane, perform your check spin, you're good to go. One of the last things we're going to talk about today is how to change this machine from static to dynamic or go in between. Common on a heavy duty wheel assembly, you're going to just statically balance it, right? We're not worried too much about dynamic instability in wheels of this size because of their overall diameter and the chassis they're obviously going on. Easiest way to do that is just make sure that you're in the correct mode, whether that's passenger car, medium truck, or heavy duty truck. So again, changing modes here with the vehicle interface. 17.5 by default would be the medium duty assembly we're working with here today. I'm going to make sure that I select the appropriate clip-on or tape weights. Again, if you're using tape weights, you're going to use the SAPE arm to identify those two inner and outer planes that you want to affix the weight to. If you're just simply going to use a nail-on flange weight, we're just going to touch that outside flange where the weight goes. That's going to identify the diameter of the circle and the distance from the hub that it's currently at. I'm also going to change this to the right width of the assembly, and I'm simply going to close the hood. The machine is default after check spin going to be in dynamic mode. To toggle back and forth between dynamic mode, the first icon here is going to allow me to do that. And I can do that at any point during the balance cycle. So if I was in static only and I want to go back to dynamic, simply press this button. It's automatically going to change. The dimension data didn't change on the wheel, so there's no need to re-enter any characteristics and perform a check spin. When you go into static mode, you're going to notice that you have two LEDs flashing back and forth on here, and that's because the machine doesn't care at which horizontal point you place the counterweight. It just needs to be affixed to the 12 o'clock position. So in this particular case, I can put 3 ounces of weight at the 12 o'clock position once that is highlighted, or I could put 3 ounces of weight on a sticky, or I could split them. I could do 1 and 2 or 1.5 ounces on each side if I'm worried about inducing some dynamic instability by putting all that weight on one plane. That about wraps us up today for a brief overview on the 9800 heavy duty wheel balancer. Don't forget to like, share, subscribe, check out our other YouTube videos, TSS Garage. Thanks.